Hello, my viewers. My name still remains Ekpenyong with Sunday. I welcome you all to my YouTube channel on PU Formal. Academy is about the academy that work with my own professional experience in PU Formal industry, especially in the production and optimization process. Now, in my presentation today, we shall be looking at the geography of forming process. The geography of forming a process. This is what we'll be looking at. Now, in my presentation today, this is just the brief introduction about the geography of forming a process because it's very bulky. So, in subsequent lesson, I'm going to further break it down into sub lessons that I will present it for more clarification. But this is just the introductory aspect of it. Now, if you look at the rate of chemical reaction, it is changes with the time. And in our elementary ideas, there are factors that affect the rate of chemical reaction, such as the temperature, the pressure, the surface area, the concentration. Are we all together? So, looking at the geography of the forming process, what will now come into our mind is the location. Location means where the forming plant is located or situated. Now, in that location, location A and location B is not the same. You understand? At times, many of my professional colleagues and others are industry forming. There are certain behavior of the forming process that at times is difficult to comprehend except you really understand the geography of the forming process. That you know that, oh, it could be the atmospheric temperature have changed. Take for example, you are producing and along the line the atmospheric condition changes. Maybe it's raining or it's changing the temperature, the atmospheric temperature or the air, whatever now change. Don't you think it will affect the way the reaction, your forming process will react and the curing process? Those are the questions you need to ask yourself as a professional. You understand? So many people do not. They are in industry, okay? The fact that they have several experience, I don't argue that is true. But this is just the secret about good product if you understand this variable and this concept very well. I think you should able to make certain adjustment to balance your PU form or chemical reaction so that you have the same density and the same targeted property such as the density, the hardness, the compression state, the elongation state, and the rest. So what are we saying here in a concept? You understand? There's what we call the altitude. Altitude of the factory. Altitude of the factory location. Now, what is this altitude is all about? You know, we mean it is the height of a place above the sea level. The height of a place above the sea level. The height of a place above the sea level. Are we all together? Now, what is the sea level? What is the sea level? The sea level, in simple terms, sea level means 0 meter. Okay, that's how I define it according to the foaming content. Sea level equal to 0 meter. You understand? Don't crack your brain. Now, what it means, the sea level, at the sea level. You'll be listening to people saying at the sea level. It therefore mean the word sea level. The sea level is not the same from place to place. It could be 44 meter, you understand, above the sea level. It could be 40 meter above the sea level. It could be 1 meter above the sea level. It could be 8,000 meter above the sea level. So as you are changing the location of the place, and that is why the foam produced in London, okay, using the same formulation may not work the same with the foam produced in Nigeria with the same variable. So these are the factor. Are we all together? And that is why I did say that you do not copy formulation, but you understand the formulation techniques. For example, someone said, I used 4.5 part per water at the sea level to produce a foam of 22. Okay, another person may use part of 4.4, okay, part of water to still get the same 22 density. Do you know why? Because this altitude affects two things: the boiling point of water and the change in atmospheric process. And what is that atmospheric process? The gas at the environment. So water at the sea level may be liquid. Water above the sea level or below the sea level can be a vapor. So that is all the behavior. That is to say, at sea level, water is at liquid state. So when this changes, it will make water behave like a gas. You know, in PU form, there are 3 types of gas that is generated. Okay, one, atmospheric temperature. That is the force of air pressure that is active on the location of the factory and the foam and around the foam system. We also have internal pressure generated from the CO2 within and outside the gas system that water react with TDI to generate that pressure. We also have back pressure. Back pressure is the pressure of the machine. So at times you are producing foam collapse, okay, and you are start wondering, oh, is a valve, is that. You start blaming the machine and the adulteration and contamination of the raw material. This almost happen when you are producing extremely low density and the atmospheric temperature changes and you don't know. So it will not affect how gases react. Okay, in that case, it will make the polymerization occur so fast. Okay, it will not allow it to work in accordance with that formulation that you intend to produce or the density. So you intend to produce density of 12. You don't know that what you are doing 9 density or 7 density. Okay, there's no way the foam will not collapse. So what you need to do is to understand the logic of the effects of this attitude to that of your foam, because it's both direct and indirect impact. You know, the pressure is equal to force over area. That is, at the sea level, the unit is 1 bar, which is equivalent to 101.3 kPa. I think I'm correct, or 2. Okay, so at the sea level it's 0, and that is why somebody, when they are speaking, they say water at the sea level. So that sea level means the best line, that if it goes below or higher, then you need to make some adjustment. So once you are trying to design a formulation, you are assuming that at the sea level of that parameters. So that's why you cannot copy formulation. Okay, because there are certain variables, you know, okay, another person do not. That is to say, for you to understand the ethics of that formulation, you need to understand the location parameters of that place to really ascertain that this formulation can work or not. You know, in that case, there is what we call positive altitude and negative altitude. So in my next presentation, we shall be looking at this at detail. When you observe this, what do you need to adjust? When this occur, what do you need to adjust? And what are the impact on the PU forming reaction? You understand? So continue to watch my lesson on your notification bell so that when I upload a new video, you'll be notified. Just like I said, I have a lot for you to learn and see how you can balance your production or process so that you will not generate process waste. Process waste generated is money lost and loss of investment. So what you need to do is to keep following up, share, subscribe so that you learn a lot. It's about academy that work with my own professional experience. Thank you. Bye bye to my viewers. I love you. Bye.